All right, my friends, let's take a look here. So a plus b to the 0, I'm hoping you just fell back on anything to the 0 power is 1. And so you just got 1 for that one. A plus b to the first, that would be equal to a plus b. A plus b squared, I guess that's the first time it gets mildly interesting. If you were to expand it out, you'd get a squared plus 2ab for that middle term, and then plus b squared. Now for a plus b to the third power, you could break it up as a plus b to the second power times a plus b. And then you'd already expanded a plus b to the second power above. And so you could replace that with the answer that you got there. And then just multiply it by the remaining factor there of a plus b. And so then you could just start distributing. So I'll distribute the a squared in first. So I'd have a cubed plus a squared b. I like to keep things alphabetical. Now I'm going to distribute the 2ab in. So I'd have 2a squared b plus, oops, plus, 2ab squared. Now let's distribute the b squared in. So we'd have plus ab squared plus b cubed. All right, and then before we quit, let's combine like terms. So we'd have a cubed, just one of those. But we had a total of 3a squared b's, it looks like. And then we had a total of 3ab squareds. And then 1b cubed. So I'm going to bring my prompt down now that that's my final answer. There we go. And this is, just kind of on an organic level, how you would do these problems. You would just use the distributive property and combine like terms, no big deal. And then if we're going about it this way, how would we expand a plus b to the fourth power? Well, you could always think of that as a plus b to the third power multiplied by another a plus b. You could replace a plus b to the third power with what we had from that previous step there, and then multiply it by that last a plus b, and then, distribute and combine like terms, just like we have, right? So you could distribute a cubed in, you'd get a to the fourth plus a cubed b plus, you could distribute the 3a squared b in, you'd get 3a cubed b plus, oops, kind of messing up there, plus 3a squared b squared. You could distribute the 3ab squared in, would get 3a squared b squared plus 3a b cubed, I think. And last, we could distribute in the b cubed. And so we'd have a b cubed plus b to the fourth. All right, combining like terms, what would we get? A to the fourth plus 4 a cubed b's plus 6 a squared b squareds plus 4a b cubes plus b to the fourth. All right, and I'm going to bring my prompt down. And that's what we would get for a plus b to the fourth power. Good, super fun. Okay, so hopefully you were able to get each of those expanded. I'm going to go back and maybe kind of put boxes around all of the final answers just to be consistent. All right, so that's how you do that. Now, we can do that, but we could file it under doable but not desirable. So for example, if I was to ask you to expand a plus b to the 7th power, or even the 5th or 6th power, this starts becoming, very doable, but very tedious. And we start getting to the point where we could lose track of some details. So let's talk about another way to get these final answers, and a way that would make it so we could skip the steps along the way. We could just jump straight to the answer. Wouldn't that be nice? So let's talk about Pascal's triangle. And I think I'll put it over here to the right. So Pascal's triangle. Oops. Okay, Pascal's triangle is a fun little thing. So there are a couple ways to define it. Here's my way, and then I can show you another way. The first row starts with a 1. And then every time you start a new row, you surround the previous row with 1s. And then the next row, you'd surround it with 1s, but then in the gap, you add the previous 2 numbers. So 1 plus 1 is 2. And then the next row, you do it again. So you surround it with 1s, and then in the gaps, you'd add the top 2 terms. So 1 plus 2 is 3, and 2 plus 1 is 3. And then surround the next row with 1s, and then fill in the gaps. There we go. So between now and the next video, what I would love for you to do is fill in the next 2 rows of Pascal's triangle. Pascal's triangle is infinite, but go ahead and fill in the next 2 rows of Pascal's triangle, and then look at Pascal's triangle and the answers that we got for our expanded versions when we expanded those binomials in the warm-ups, and see if you can see anything that they have in common. And then you're probably well on your way to knowing the trick for how to be able to skip all the steps for problems like what you see in the warm-up.